To geometry. This is your teacher, Mrs. Belyakov. Today's lesson, lesson 91, is Introduction to Trigonometric Identities. The purpose of this lesson is to express a function in terms of another. We're going to express sine in terms of cosine and tangent. We're going to express cosine in terms of sine and tangent. And we're going to express tangent in terms of sine and cosine. In the new concepts of your book, you're going to find a trigonometric identity. The main one is sine to the second power of an angle plus cosine to a second power of an angle equals 1. And it works for every angle. That's why it's a trigonometric identity. Let's try with two different angles so we can prove that it's true. Let's see. Let's begin with 90 degrees. It says sine of 90 degrees to the second power plus cosine of 90 degrees to the second power, that must equal 1. The sine of 90 degrees is 1, and it says I have to raise it to the second power, plus cosine of 90 degrees is 0, and it says I have to raise it to a second power, and that must equal 1. 1 to the second power, I'm going to write it here. 1 to the second power is 1, and 0 to the second power is 0. That must equal 1. Therefore, it's true. 1 plus 0 is 1. Sorry for that. And that equals 1. That's how we prove the trigonometric identity. Now let's try with 30 degrees. Sine to the second power of 30 degrees plus cosine to the second power of 30 degrees. That must equal 1. Let's see in our calculators how much is the sine and cosine of 30 degrees. Sine of 30, 1 over 2, cosine of 30, square root of 3 over 2. So the first one says 1 over 2 raised to a second power plus cosine of 30 degrees, according to the calculator, is square root of 3 over 2, all of that raised to a second power. That must equal 1. 1 to a second power, 1. 2 to the second power, 4. Square root of 3 to a second power, 3. 2 to the second power, 4. That must equal 1. So let's add. The fractions now have equal denominator. So 1 plus 3 is 4 over 4. That equals 1. That is correct. That is a way of proving that this is a trigonometric identity because it works for any given angle. Now let's see in example number 1 how we can use that. It says, find the sine of the angle if cosine of the angle equals 0.5. So I'm going to rewrite the trigonometric identity. I'm going to rewrite it here, so that's what we're going to use. Sine to a second power of x plus cosine to the second power of x equals 1. I've been writing x, but the statement is using theta. So let's change that so you don't get confused. It's a variable. We can use a variable and exchange it for any given angle. But here, since they're using theta, I'm going to use theta so you don't get confused. So let's substitute. We're finding sine, and they're giving us cosine of the angle, which is 0.5. Okay, so sine to the second power of theta plus 0.5, substituting cosine of the angle, to the second power must equal 1. Let's simplify the power first. Sine to the second power of theta plus 0.5 to the second power, according to your calculators, is 0.25. That equals 1. Remember, we're isolating sign, so I have to get rid of the 0.25 with the inverse operation. I'm going to bring it to this side of the equation, subtracting. So sine to the second power of theta equals 1 minus 0.25. Let's simplify this. Sine to the second power of theta, 1 minus 0.25, 0.75. I'm not done because I have a second power here, so I have to simplify that. Opposite operation of a second power is a square root. So let's bring it to this side of the equation, to this side of the sheet, sorry. Sine to the second power of theta equals 0.75. I rewrote it so we can simplify it on that side, right? Inverse operation of the exponent, we said it was the root. So sine of theta equals the square root of 0.75. And according to your calculator, in this case, sine of theta, square root of 0.75 is 0.87. Since they're asking us for sine of theta, and we got to that point, we're done. Let's see example number 2. It says, express cosine of theta using only sine of theta. Let's rewrite the formula. It says sine to the second power of theta plus cosine to the second power of theta equals 1. I'm trying to express cosine. That means I have to isolate cosine. To isolate cosine, I have to bring sine of this to the second power of theta to this side of the equation. So, sorry for that. Cosine to the second power of theta equals 1. Here we have a plus, right? So inverse operation minus sine to the second power of theta. Let's keep on simplifying because I have a second power here. So cosine of theta equals inverse operation of second power would be square root of all of this. 1 minus sine to the second power of theta. Okay, since cosine is isolated, then we're done. That's the answer. And example number 3 says, express tangent of theta using only sine of theta. In your new concepts on the book, you have another trigonometric identity, which says that tangent of theta equals sine of theta over cosine of theta. They're asking us to express tangent using only sine. So what I have to change here is cosine. But if you notice in the previous example, we isolated cosine and said that it equals the square root of 1 minus sine to the second power of theta. So we can use that here. Let's rewrite this. Tangent of theta equals sine of theta, all of that over square root of 1 minus sine to the second power of theta, which was the previous answer you found. Since tangent is already expressed using only sine of theta, then we're done. These trigonometric identities, you can find them in your formula sheet, the one we were working with since the beginning of the class. It's something that looks like this. I also attached it to the assignment on Google Classroom. To finish this lesson, let's read something I wrote for you. It says, thanks God, because in Him we may find our true identity. Well, guys, that's all for today. See you next class.